Welcome to the next lecture of boiler under the edges of chemical process utilities. Now before we start, let's have a brief outlook about the topics which we covered in the last lectures. We discussed about the stoker fired boilers, in which we talked about the better combustion efficiency, as well as we talk about the different parameters required for the proper maximization of the fuel efficiency of the boiler, that is the bed size of the fuel coal, then air supply, as well as how we can manage or how we can configure the bed of the fuel over different type of grades. Then we had a discussion about the pulverized fuel boiler, in which we talk about the fine particles pulverization process, and we had a discussion about that what is the role of the size of the fuel particles in the boiler efficiency. We discussed about the fluidized bed combustion boilers. In this we discussed briefly about the phenomena of fluidization and how this phenomena of fluidization helps in the boiler efficiency. Apart from this, we discussed two boilers under the edges of high pressure boiler system, Lamont boiler and Benson boiler, and we discussed the various advantages associated with these kind of boilers. So in this context, in this particular lecture, we will discuss about the Loeffler type of a boiler, then SCHMIDT-HARTMANN Boiler, VELOX Boiler, and then we will go for the concept of performance evaluation of boilers. So let us take up the first boiler of this lecture, that is the Loeffler boiler. When we were discussing about the concept and the basic anatomy of Benson boiler, there are certain you can say the difficulties or disadvantages associated with the Benson boiler, although it is a high pressure boiler, but there are certain things associated with it. So the major difficulty which people experienced in Benson boiler is the deposition of the salt and sedimentation on the inner surface of water tubes. Now see, if you recall that the Benson boiler, the tube's diameter was small. So sometimes it's advantageous, but if any kind of a sedimentation, debris or salt may get deposited over the period of time, then there may be a chances of a choking. So if this deposition is there, then of course it will reduce the heat transfer and ultimately the power generation or steam generation capacity would be adversely impacted. So, and if you keep on bearing this thing, then this further increase the danger of overheating of the tubes because of this particular salt deposition, because of the high thermal resistance. So people thought about this particular aspect, and this particular difficulty was resolved in the Loeffler type of boiler by preventing the flow of water into the boiler tubes. So the most of the steam is generated outside from the feed water using part of superheated steam that is coming out from the boiler. So when you are carrying out this operation, you may require the pressure feed pump. So the pressure feed pump draws the water through the economizer and delivers it into the evaporator drum. So by this way you are also maintaining the energy efficiency of the boiler. Now this is you can see the basic anatomy of the boiler or Loeffler boiler. Now here again I am repeating that the basic ingredient of or a basic anatomy of all the boilers are similar. Only thing is that only difference is in the different type of parameters and a configuration. Like here you will see that exhaust steam, high pressure, low pressure pumps. This is the stoker type of combustion chamber. Here you will find the radiant superheaters, then steam preheaters. You are also having the exhaust gas, feed pump and feed water from hot well. So you see that the Loeffler Benson type of a boiler, all these Lamont type of a boiler are similar. But the basic difference exists here, that is the external steam generation part. Now here you are having one evaporating drum supplying the continuous supply of a feed over here. These are the mixing nozzle and here is steam circulating pump. So by this way you are generating the steam externally and then you are submitting it into the main boiler arena. So usually about 65% of steam, it's usually coming out of the superheater, that is here, is usually passed through the evaporator drum in order to evaporate the feed water coming from economizer. So the steam circulation pump or steam circulating pump usually draws the superheated steam from the evaporator drum and is used to pass through the radiant superheater, which is situated here, radiant superheater and the convective superheater. So by this way you are maximizing the efficiency, energy efficiency, and remaining 35% of the steam usually it's coming out from the superheated is supplied to the high pressure steam turbine. So the steam coming out from high pressure turbine is passed through a reheater before supplying to the low pressure turbine. Here you see that this is the low pressure turbine and this is the high pressure turbine. So the amount of steam generated in the evaporator drum is equal to the steam tapped, that is 65% from the superheater. Now the nozzle usually which distribute the superheated steam through the water into the evaporator drum, they are of special design to avoid the priming and noise. Now priming is again a very well known phenomena and a well tested phenomena in the boiler, just to remove any kind of air entrapment in the boiler system, because usually air does not carry any kind of heat value and also obviously it is an hindrance to the steam distribution as well as the water distribution network. So the priming is quite essential for any startup of the boiler. Now this type of a boiler, that is a Loeffler boiler, they can carry a high salt concentration than any other type of a boiler, and it is more compact than indirectly heated boiler having the natural circulation. So these qualities fit it for a land or a sea transport power generation. Now Loeffler boiler with a generating capacity of say 94.5 tons per hour and the operating at say 140 bar, they have already been commissioned industrially. Now let us talk about another type of a boiler, that is called the SCHMIDT-HARTMANN boiler. Now usually, as I told you that the anatomy of all the boilers are almost similar. Now here the SCHMIDT-HARTMANN boiler, the operation of the boiler is similar to an electric transformer. Now usually the two pressures are used to affect an interchange of energy. So it is working the concept of interchanging of energy. The primary circuit, the steam at 100 bar is usually produced from distilled water. So, when we are using the distilled water, that means the chances of scales or hardness is minimum. Now, this steam is passed through the submerged heating coil, which is located in an evaporator drum. The high pressure steam in this coil possesses sufficient thermal potential and steam at 60 bars with a heat transfer rate of 2.5 kilowatt per meter square degree Celsius. Usually it is generated in the evaporator drum. Now, here you see the anatomy or pictorial diagram of SCHMIDT-HARTMANN boiler. Again, this is the chimney for exhaust gases. We are having the cool here a cool air inlet, then the blower. Obviously, when we are having the air inlet, obviously there must be a blower. Here you see that there are different type of a circuit, secondary circuit, and this is the primary evaporator. And to maximize the efficiency repeatedly, that this is there is a superheated, and you see here this is the primary separator. Apart from this, we are having the NRV, that is non-return valve, and a water drum and a feed pump to supply the continuous supply of water. But to maintain the water at appropriate temperature, this is the feed preheater, so that there may be any thermal shock can be avoided. Apart from this, the circulating hot air and this air preheater. So, you see that most of the accessories and mountings of these boilers are attributed to the either safety or maximization of energy. So, the steam produced in the evaporator drum from impure water is further passed through the superheater and then supplied to the prime mover, as you can see in this particular figure. The high pressure condensate usually it formed in the submerged heating coils, and this high pressure condensate is circulated through a low pressure feed heater on its way to raise the feed water temperature to its saturation temperature. So, the knowledge about this is quite essential, that what should be the saturation temperature under the given pressure. So, if we know all these things and we perform this thing, optimize this thing, so only latent heat is need to be supplied in the evaporator drum. Now, natural circulation is used in primary circuit, and this is sufficient to effect the desired rate of heat transfer and to overcome the thermal siphon heat to about 2 meter to 10 meter. Again, in this aspect the optimization usually do occur. So, in normal circumstances, the replenishment of distilled water in the primary circuit is not required, as every care is taken in design and construction to prevent any kind of a leakage. So, the proper water balancing is always there. But as a safeguard or as a safety safety measure of a boiler, as a safeguard against the leakage, a pressure gauge and a safety valve are fitted in the circuit. So, it is quite evident with the figure. Now, let us talk about another type of a boiler, that is called the VELOX boiler. Now, again it offers to the same phenomena. Now, you see here we are having the economizer, we are having feed water tank, feed pump, fuel tank for supply of energy. This is the combustion chamber, and there is a gas turbine over here, apart from air compression system, superheater. So, all these things are the essential things are there. Now, the concept is that when the gas velocity exceeds the sound velocity, the heat is transferred from the gas at a much higher rate than rates achieved with subsonic flow. So, this is the basic phenomena. The advantages of this particular theory Usually they are taken to obtain a large heat transfer from a small surface area in this particular type of a boiler. Now usually air is compressed to say 2.5 bars with the help of compressor run by gas turbine before supplying to the combustion chamber to get the supersonic velocity of the gases passing through the combustion chamber and gas tubes apart from the high heat release rates. So basically that you need to create the supersonic velocity. Now the burned gas after the combustion or burned gas in the combustion chamber, they are passed through the annulus of the tube. So the heat is transferred from gases to water while passing through the annulus to generate the steam. Now the mixture of water and steam, whatever being formed during the course of time, they then passes into a separator which is so designed that the mixture enters with a spiral flow like this. The centrifugal force, they are whatever being produced, they cause the heavier water particles to be thrown outward on the walls. Now this effect separates the steam from water. See, this is again a very crucial phenomenon, let me tell you, because you see that when we were discussing about the different type of a boiler, there is a steam chest and a water level, and all these things are well, you can say, optimized. So separation of steam from water is quite essential, otherwise the entire system will get collapsed. So this is again separation of steam from water is again a very crucial phenomenon. Now the separated steam is further passed through the superheated and then supplied to the prime mover. So you may get the superheated steam from this particular juncture. The water removed from the steam in the separator, which is again passed into the water tubes with the help of a pump. The reason is that you cannot say that water, let the water go, but the thing is that because whenever you are using, as I told you in the previous lectures, that every drop of water costs. So you need to conserve the water at this juncture also, and also the water possesses the significant heat value. So the gases coming out from the annulus at the top, they are further passed over the superheater, where its heat is used for superheating the steam which we have already circulated, which we have discussed in the previous slides. Now the gas, whatever is coming out of superheater, they are used to run a gas turbine as they carry sufficient kinetic energy. So you need to play with the dynamics or thermodynamics to get the sufficient kinetic energy. The power output of the gas turbine is used to run the air compressors, and the exhaust gases, whatever being coming out from the gas turbine, they are passed through the economizer to utilize the remaining heat of the gases. So sometimes you may require some extra power to run the compressor. Usually it is supplied with the help of electric motor. Feed water of say 10 to 20 times the weight of steam generated is circulated through the steam power plant, the tube with the help of a water circulating pump. So this phenomena usually prevents the overheating of metal walls, and trust me, the overheating of these metal walls are extremely common phenomena in boiler system. Now let us come to the remaining part of this particular concept of a boiler, and that is a very crucial part, a performance evaluation of boilers. Now, see, during the entire course of time, we always talked about the efficiency of a boiler, efficiency of the fuel, efficiency with respect to the economics, efficiency with respect to the environment. So, all these things must be evaluated properly, and by this way we can object that the boiler performance. And the boiler routinal evaluation of a boiler performance is again very important phenomena, because this particular diagnosis gives you an idea that whether your boiler is functioning well or there are some malfunctioning or something goes wrong within the boiler system. So, the performance parameters must be analyzed first, that under what category, under what parameters would like to evaluate the boilers. So, the performance parameter of the boiler, they are like efficiency, evaporation ratio. Now, these things they reduces over the period of time due to sometimes poor combustion, maybe because of the wrong choice of the fuel, maybe because of the low circulation or high circulation of air, etc. Then there may be certain problems associated with the heat transfer surface, may be attributed to falling, scaling, etc. This may be attributed to the poor operation, very rapid load fluctuation, maybe sometimes leakage, that is leakage or condensate recovery, malfunctioning of the preheater. So, all these things are attributed under the edge of maintenance. Even if you see that for a new boiler, reason for such deteriorating fuel quality, water quality is again very important. Say if you are having the water with the high level of turbidity, high level of total solid TDS or high level of hardness, it can result, all these things can attribute to the poor boiler performance. So, the boiler efficiency tests usually help us to find out the deviation of a boiler efficiency from the best efficiency, and always you can assess that what are the problematic area, and by this way you can perform some of the corrective measures which are quite essential for the smooth functioning of the boiler. Now, again I am repeating this, that the purpose of performance test is that what is the efficiency of the boiler, and you need to find out the evaporation rate ratio of the boiler, because all these things which we discussed in the previous slide are embedded in it. So, the purpose of performance test is to determine the actual performance and efficiency of boiler and compare it with the design values or norms. You see there are various norms attributed by the different government organization, because sometimes if you are not getting the proper efficiency, that may be one of the reason may be the unburnt fuel, and this may create the environmental problem. And of course, if you are not having the proper evaporation ratio, that means your tubes are not functioning proper. I mean, this is you can say the pressure vessel, and any kind of a choking, any kind of a malfunctioning of the tube may create a severe problem to the safety of the boiler. So, that is why every government or state government, they are having their design values or norms. So, usually these norms or the values, these are an indicator for tracking day to day and season to season variation of the boiler efficiency. And of course, energy and economic efficiency are also very important, and you need to improvise all these things. So, when we talk about the boiler efficiency and evaporation ratio, so there are set mathematical formula. Say if we talk about the boiler efficiency, this is heat output over heat input multiplied by the 100. In some other words, we may say that heat in the steam output, usually reported in kilocalories, over heat in the fuel inputs, that is attributed to the again kilocalorie multiplied by 100. Now, when we talk about the evaporation ratio, that is the quantity of the steam generation over the quantity of the fuel consumption. So, these two things are important. Now, as I told you that every state government, every country, they are having their own norms, standards, codes, etc. And reason is quite obvious that boiler is a pressure vessel, as well as it may create the problem of environment, it may create based on the other parameters, it may create the problem of safety. So, every country, they are having their own codes, standards for the smooth functioning of the boiler, like Indian boiler regulations, etc. Similarly, we do have British standards, and they are referred as BS 845 1987. This describes the method and condition under which a boiler should be tested to determine its efficiency, because there must be some characterization, there must be some standards, so that we can or protocols through which we can determine the efficiency. Now, for the testing to be done, the boiler should be operated under steady load conditions and generally full load. That means based on the rating, for a period of say 1 hour, after which the reading would be taken during the next hour of steady operation to enable the efficiency to be calculated. Now, usually as based on the mathematical relationship, the efficiency of the boiler is quoted as the percentage of the useful heat available, expressed as a percentage of the total energy potentially available by the burning the fuel. This usually expressed on the basis of gross calorific value, sometimes referred as GCV. Now, when we talk about the various standards, especially the British standards, this deals with the complete heat balance, and it has usually two parts. One is that part 1 deals with the standard boilers, where the indirect method is specified, whereas in part 2 this deals with the complex plant, where there are many channels of heat flow. Now, in this case, both the direct and indirect methods are applicable, either partially or in toto. Another standard is again very common in practice, that is ASME, that is American Society for Mechanical Engineers, their standard PTC 41 Power Text Code for steam generating units. Now, usually this consists of part 1, that is the direct method, and sometimes called as input output method. Another thing is that part 2, the indirect method, and that is also called the heat loss method. See, in Indian context, we are also having our BIS code, Bureau of Indian Standard, BIS code, IS 8753, that is Indian Standard for Boiler Efficiency Testing. Usually the most standards for computation of boiler efficiency, this including IS 8753 and BS 845, they are designed to spot the measurement of boiler efficiency. Now, invariably all these standards, they do not include blowdown as a loss in the efficiency determination process. Now, I am telling you this because when we go for the blowdown, it also carries the heat value, it also carries, because it is usually when it discharges from the boiler, it usually has the temperature equivalent to the boiler, as well as the significant quantity of water. So, if we are not including this blowdown, then obviously there is a flaw in the standard. Now, basically boiler efficiency one can test by the different method. One is the direct method, where the energy gain of the working fluid, that is water and steam, is compared with the energy content of the boiler fuel, maybe oil, maybe gas, or maybe coal. The indirect method, where the efficiency is difference between the losses and energy input. Now, when we talk about the direct testing method, or it is also known as the input output method, this is due to the fact that it needs only the useful output, that is steam, and the heat input, that is fuel, for evaluating the efficiency. Now, this efficiency can be evaluated using the formula called the boiler efficiency, that is heat input over heat input multiplied by 100, and efficiency, that is heat addition to the steam over the gross heat in the fuel input multiplied by the 100. So, when we talk about the boiler efficiency under the edges of direct testing method, it is referred as the steam flow rate Q, steam enthalpy Hg, and a feed water enthalpy Hf, that is the fluid enthalpy, over fuel firing rate Q and GCV, that is the gross calorific value multiplied by the 100. Now, there are various advantages associated with the direct testing method, that plant people can evaluate quickly the efficiency of the boiler. There requires a very few parameters for computation, quite evident from the previous mathematical relationship, and there needs a very few instruments for monitoring. So, these are the advantages associated with this particular slide. But when there are advantages, obviously you cannot overlook the importance of disadvantages. So, one disadvantage is that it does not give a clue to operator as why efficiency of the system is lower. Again, it is a very major disadvantage. Does not calculate various losses accountable for various efficiency level. Again, evaporation ratio and efficiency, sometimes they may mislead. So, if the steam is highly wet due to the water carryover. Water carryover is again very important phenomena, we will discuss in due course of time. So, at last in this particular lecture, we discussed the various parameters attributed to the performance of the boiler, and discussed about that what the major parameters are required for the performance evaluation of the boiler, as well as we discussed a couple of high end boilers at the start of this lecture. Again, you may look for different references. Apart from this, we have discussed a couple of standards, BIS code, British standard code, American standard codes, etc., for the as a reference material. So, in case if you are facing any difficulty, you may look to all these references. Thank you very much.